Remember when robots were just clunky arms in factories or funny videos online? Fast forward to 2025. They're saving lives in surgery, farming our food with lasers, and learning tasks almost like humans do. Robotics just had its biggest decade ever, and here's what you need to know. The rise of humanoids, the big breakthrough is NVIDIA's Isaac GR00T N1, an open foundation model that gives robots generalized reasoning and manipulation skills. Instead of one robot being trained for one task, we're now seeing shared robot brains that can learn many skills and pass them across platforms. Boston Dynamics also unveiled a fully electric Atlas robot. Unlike the hydraulic prototypes we saw a decade ago, this new Atlas is designed for real-world work and commercial deployment. And companies like Figure AI are scaling up manufacturing, building a factory to mass-produce humanoids, and even running home-based pilot tests in 2025. Back in 2015, humanoids were mostly research stunts. Today, we're moving into real pilots with logistics giants and production lines designed to scale. Warehouses at scale. Warehouses have always been the front line for robotics, and Amazon shows just how far things have come. In 2015, automation meant conveyor belts and simple mobile bases shuttling bins around. Useful, but limited. By 2025, Amazon runs more than 750,000 robots across its fulfillment centers worldwide. These aren't just moving boxes, they're picking, sorting, scanning, and orchestrating items alongside human workers at fleet scale. Many tasks that once required large teams are now handled faster and more safely with robotics. And the next wave is already arriving. Agility Robotics' Digit Humanoid has been introduced into warehouses through a robot-as-a-service model, giving companies access to humanoid labor without the massive upfront investment. Digit's ability to walk, carry, and interact with shelves means it can fit into spaces designed for people, something mobile bases could never do. The direction is clear. Warehouses are becoming fully automated ecosystems where fleets of robots work in sync, guided by AI systems that optimize storage, routing, and fulfillment. Looking ahead, we may see warehouses that run almost entirely on robotic labor, with humans focusing only on oversight and complex problem solving. For logistics, it's not just about speed, it's about creating supply chains that can adapt in real time to demand, inventory shifts, and even global disruptions. Surgery gets smarter. In healthcare, robotic surgery has just taken one of its biggest leaps forward in decades. A new Vinci 5 system received FDA clearance in 2024 and gained CE marking in early 2025, opening the door for widespread use across the US and Europe. What's new? For surgeons, the difference is night and day. The system provides vastly improved ergonomics, real-time haptic feedback, and higher precision instruments that make delicate procedures safer and more efficient. It's also built with far more computing power, which allows for richer data capture, meaning every procedure helps the system learn and refine. For hospitals, this isn't just about technology, it's about reach. The Vinci 5 is designed to support a broader range of specialties than earlier versions, moving robotic surgery beyond urology and gynecology into areas like thoracic, colorectal, and general surgery. That means more patients in more departments can benefit from less invasive, faster recovery procedures. And compared to 10 years ago, the contrast is stark. Back in 2015, robotic surgery was still considered a premium option, limited to a few procedures and only found in top-tier hospitals. Today, we're entering an era where robotic systems are not just proof of concept. They're becoming mainstream medical infrastructure, backed by real-world outcomes and demanded by both surgeons and patients. Farming goes autonomous. 10 years ago, farms mostly relied on GPS steering and human operators. Automation was basic, and spraying meant covering whole fields with chemicals whether weeds were there or not. By 2025, things have shifted dramatically. John Deere has rolled out autonomous tractors, orchard vehicles, and electric mowers that can navigate fields without a driver. Their See and Spray system uses AI and computer vision to identify individual weeds and apply herbicide only where it's needed, cutting chemical use by up to 90%. Meanwhile, startups are pushing the boundaries further. Carbon Robotics Laser Weeder G2 uses high-powered lasers to burn weeds out of the soil with millimeter accuracy, helping farms reduce costs and move toward organic production without pesticides. The payoff is clear: lower costs, fewer labor shortages, and more sustainable farming practices. And looking ahead, these robots won't just operate alone. They'll connect into climate-smart agriculture networks, systems where AI monitors soil, weather, and crop data, then coordinates fleets of machines to optimize food production and sustainability on a global scale. The platform shift behind all these breakthroughs is a deeper shift: the rise of foundation models for robots. For years, robotics depended on hand-coded rules and narrow vision systems. A robot might be trained to do one very specific thing, like move a box or follow a line, but it struggled the moment conditions changed. Now, with models like NVIDIA's Isaac GR00T N1, robots are learning in an entirely new way. Instead of starting from scratch, they can train on massive simulation pipelines that generate millions of lifelike scenarios, everything from walking across uneven ground to manipulating objects in a warehouse. This virtual training means a robot can practice thousands of lifetimes worth of experience before it ever touches the real world. The result is a new kind of flexibility. Robots are no longer stuck in the one robot, one task paradigm. They can generalize skills, transfer learning across different machines, and adapt to environments that were once impossible. That's why we're seeing humanoids, warehouse bots, and even farm robots suddenly leap forward, because they're all benefiting from the same underlying model architectures and simulation platforms compared to 10 years ago. The difference is striking. Back then, robotics was limited by brittle code and narrow AI systems. Today, we're entering the age of multimodal, agent-like models that can plan, reason, and act in real time. The reality check: it's not all smooth sailing. Robotics still faces tough challenges. Hardware is a big one. Batteries limit runtime, motors overheat, and joints wear down fast under stress. Keeping humanoids stable and safe for hours outside of controlled demos is harder than the highlight reels suggest. At global events like China's World Humanoid Robot Games, many robots still wobble, fall, or freeze in unpredictable settings, showing just how difficult real-world reliability is. There's also the issue of scaling production. Building a dozen prototypes is very different from producing thousands of affordable, durable robots. Reports around projects like Tesla's Optimus show how ambitious timelines don't always match reality. And even when the hardware works, integration is messy. A robot that performs perfectly in the lab can struggle in a chaotic warehouse or factory. So yes, the progress is huge, but we're still in a transition phase where moving from impressive demos to everyday deployment remains the biggest hurdle. The takeaway: here's the big picture. In warehouses and hospitals, robots aren't just experiments anymore. They're delivering real, measurable returns. They're speeding up fulfillment, reducing surgical complications, and proving their value on a daily basis. Farms are following close behind, with autonomous tractors and laser-guided weeders tackling labor shortages and chemical use at scale. And humanoids, once seen as flashy novelties, are now entering serious pilot programs with logistics companies and manufacturers. But the real breakthrough isn't about any single machine. It's about the shift in how robots are built and trained. Scalable manufacturing means robots can finally be produced in large numbers, and shared generalist AI models mean they can learn faster, adapt to new environments, and pass knowledge from one platform to another. Together, Those two forces set the stage for robotics to move from impressive demos to everyday infrastructure. The kind of technology that quietly underpins how we shop, eat, travel, and receive healthcare. If you want more deep dives like this, make sure you follow and subscribe. And if you want hands-on AI skills you can apply to your own business the very next day, from content creation to automation, join us at AI Cyclops, our one-day workshop in Milton Keynes. No jargon, just practical wins.